So today we are doing the kangaroo maths competition question 2019. Last week we did question 11 to 20. So today we'll cover question 21 to question 30. Question 21. 1 minute. A square has two of its vertices on a semicircle and the other two on the diameter of the semicircle, as shown in the diagram. The radius of the circle is 1 cm. What is the area of the square? So I draw a bigger diagram showing the radius is 1. You want to label further to form equation, label the diagram. So we know it's a square, and the square must be has a midpoint, the center of the circle as midpoint of one side on the diameter. So here is x and x. Then here 2x. Therefore, we can now form using Pythagoras theorem, 2x squared plus x squared, 4x squared equal to 1, 5x squared equal to 1, x squared is 1/5. The area of the square is 2x times 2x is 4x squared. So 4/5. Yeah. Next question. Question 22. Two dots are marked on in a disc that is rotating around its center. One of them is 3 cm further than the other to the center of the disc and move at a speed that is 2.5 times faster than the other. What is the distance from the center of the disc to the far point? So they draw a diagram. One nearer, we say RCM from the center. Then one of them is 3 cm further than the other. So the distance is R plus 3 cm. 3 cm further than the other. And the speed is 2.5 times as fast as the other. So if this speed is V, then 2.5 V for the outer point. What is the distance from the center of this far point, of this second point here? The we use time for one rotation, one complete revolution. Time T, capital T, time for one complete rotation. In the time T, the inner dot move one full circle. So since the distance from the center is R, the circumference will be 2 pi R. So distance traveled by the inner dot is 2 pi R. In the time T, the outer dot move one full circle. Because it's the disc rotating. So the point marked on the disc. So the disc rotating. So they have they are like, they move according to the rotation of the disc. So 2 pi R plus 3 is the circumference of circle for the outer dot. But we are told the speed is 2.5 times. Speed of inner dot the distance traveled divided by the time taken, time for one rotation, 2 pi r over t. For outer dot, 2 pi r plus 3 over t. The outer dot move more distance because it is further away, moving faster. Although both are on the disk and the disk is rotating. When you are very near the center of the circle, you move very small speed. If you're at the center of the circle, you're not moving at all. So the outer dot is faster 2.5 times. One outer dot 2.5 times as fast as the inner dot. So we can form the equation 2 pi r plus 3 over t is 2.5 times 2 pi r over t. 2 pi over t can cancel on either side. So we have r plus 3 equal to 2.5 r. 2 pi over t cancel already. So then we have 2.5 r minus r 1.5 r equal to 3. Then r is 3 divided by 1.5 equal to 2. We want for the outer point. So r plus 3 is 5. Answer is E lah. Question 23. The integers from 1 to 99 are written in ascending order without gaps. The sequence of the digits is then divided into triplets of digits. So 1 to 99, we group in triplets. 1, 2, 3, 1 bracket, 4, 5, 6, 1 bracket, 7, 8, 9 bracket, and continue until they reach the last 899. 899 is the last bracket. So which of the following is not one of the triplet? Out of these 5. So we want to organize, and in order to be able to see better, it depends on how you organize. We know the first 9 digits, 1, 2, 3, 4, 5, 6, 7, 8, 9. So we can separate it from those numbers with double digit, from 10 to 99. Use a dot, dot, dot. Now, how to organize? We write vertical. Since the first 9 digits already by themselves, 3, 3, 3, we start with 10, 11, 12, and right until we can get 2, 2, 2. 2, 2, 2 is 21, 22, then 23. The triple 2 will occur at 22 join to 23. So we count how many numbers. So if I write horizontally, it may be harder to count. Now we know like that 2, 4, 6, 8, 10 I count. 10 to 21 is 12 numbers. 21 minus 10 is 11 plus 1. Okay, 12 numbers. 12 numbers means 24 digits. So up to 21, you have 24 digits. Okay, because there are 12 numbers. So all will be grouped together already, because divisible by 3, 24 can be grouped into 8 brackets. 24 by 3, 8 brackets. Can show this a little bit. So until 0 to 1, 8 bracket. So the 9th bracket will be 2, 2, 2. So 2, 2, 2 is one of the triplet. We want the one that is not one of the triplet. So it looks like we have to examine one by one. the next number we want to try is C is 444. So we write until 10 to 45. We know the 444 occurs when we move from 44 to 45. So we count how many numbers. 10 to 45, how many numbers? 10 to 45, 45 minus 10 is 35. Add 1, 36 numbers. Like if 1 to 10, 10 minus 1 is 9. But 10 numbers, 1 to 10 is 10 numbers. So when you subtract, you must add 1. So 36 numbers means 72 digits, which can be divided by 3. So we can have divide 3, 18 brackets. And 24 bracket, 24 bracket. Like that, 101 until the 72 numbers will be 4, 4, 5. The last bracket, 4, 4, 5. 72 digits. So you cannot have 4, 4, 4 because it's exactly 72 digits, all exactly 3 numbers in one bracket, 24 brackets. So answer which of the following is not one of the triplet is 444. You can see that after 444, the next number 45 will be followed by 46 and then 47. So because 445 is a triplet, then 464 is also a triplet. C we don't have to do already. We know it's in the one of the triplet. Just for the sake of knowing, we also now check 646. So to check 646, we know it's 64 and join to 65. 64 join to 65. 10 to 65. So 65 minus 10, 55. Plus 1. Plus 1. So 56 numbers, 112 digits, not divisible by 3. You know, it's like 1 extra. So the last digit 5 cannot be in. Because 112. So the last number 646. 5 will go to the next bracket. So 646 is inside the triplet, one of the triplet. And 888. So you know, after doing at first not so like say easy to think. Now we are familiar already. Want to go 888, you must go 88 and 89. So 646 then. So 10 to 89 to see whether 888 is a triplet. So how many numbers? 89 minus 10, 79, add 180 numbers. 10 to 89, 80 numbers. Digits double, 160 digits. Then the multiple of 3 is 159, divisible by 3. So the last digit 9 is not in. So 888 will form a triplet. So what you should learn from this question, the solution is if you write vertically, I feel you can visualize better. If you write horizontally like that, you can still do, but maybe when you count, it's harder to think of counting how many digits. Question 4. Wait, I forgot. Okay. How many planes pass through exactly 3 vertices of a given cube? Is it only one plane? Two, must be 3 vertices. Yeah. There are planes that pass through 4 vertices, like one face. The top face is a plane. It has 4 vertices. You only want those that have exactly 3 vertices. How many such plane? So we will start with choosing 3 points. We got 8 points. The cube got 8 vertices. Some planes pass through 4 vertices. Some plane pass through 3 vertices. Okay. 2 vertices cannot. 2 vertices, the plane can be many planes. Can rotate around the plane. 2 vertices, like the pages of a book. The what called the seam that joins the book. All the pages pass through the edge of the book. A lot of plane. So a plane for the cube, either 4 or 3 vertices. So we only want those that pass through 3 vertices. But if we 8 points, choose any 3 point, we get all the triangle. All the triangles. Some of the triangle is on the face. So the plane pass through 4 vertices. The triangle is in the plane that pass through 4 vertices, and some pass through only 3 vertices. Total 56. 8 choose 3. 8 point choose 3 point. It is 56. The triangle on each face lie in a plane that pass through 4 vertices. So those in the plane, if we choose 3 points, we get a triangle. This triangle will be in a plane that pass through 4 vertices. So one face, we can have 3 triangle. 4 choose 3. Just take the top face. 4 choose 3 is one a triangle. So 4 triangle for one face. And there are 6 faces. So number a triangle on each face. 4 choose 3 times 6. All these 24 triangle, all will have 4 vertices. The triangle lie in a plane that will pass through 4 vertices. In other words, the triangle is part of the big plane. That big plane has 4 vertices. Triangle is 3 points on the plane. So we don't want this type. We want those that exactly 3 vertices. So we must subtract. Here is some are this 56. Some have 4 vertices. Some have 3 vertices. Then the next type, the triangle with diagonals of opposite faces lie in planes that pass through 4 vertices. Let me show one example. What do you mean by diagonal of opposite face? This triangle, you see here, the front face has one diagonal. The face at the back, another diagonal. So if you form triangle, 4 choose 3, all will have 4 vertices. You can see the blue square, blue rectangle, 4 vertices. If you choose 3 points from here, then the triangle is in a plane that pass through 4 vertices. So the diagonals of opposite face. front face and back face. This is the so there are two diagonals for each face. If you take the front face, the second diagonal is this way in the front face, and for the back face, so for front and back, we have planes that has 4 vertices, and if we form triangle using these 4 vertices, 4 choose 3, they will be in the plane that pass through. We don't want this. We want to subtract all this away because they have in the plane that has 4 vertices. Then we choose the side face, the diagonal, and opposite the right side, there is the left side. Opposite face, opposite diagonal on opposite face. Again, 4 vertices. So there are 2 such diagonal for the left and right. For the right face, the diagonal can slope the other way. So again, this we don't want. Triangle inside this plane, you got triangle, but they are in the plane that has 4 vertices. Then we can choose the top face and the bottom face. Opposite, opposite faces, top and bottom opposite. Okay. So all this 4 choose 3, so you get 4 triangle for all the 6 plane, for all this 6 plane. 4 choose 3. This one front back, then left and right face, and then top and bottom face. So pair the faces, opposite pair. So each time we choose 4 choose 3, we get a triangle, and there are 6 of them. Is 6 times 4 is 24. All these will have be in the plane with 4 vertices. We also don't want, so we have to subtract these 2 away. We can see that there are no more 4 vertices one like that, either on the face or on this diagonal of opposite face. So we have 56 minus 24 minus 24 minus 48 is 8. The answer is 8. But this is only one way of doing it. We count all the triangle and subtract those that have 4 vertices one. So remaining will be only 3 vertices one. If we look at the actual triangle, let's see the this is only 3 vertices one. If we take the top face, the diagonal, you see this is also a diagonal. All triangles have 3 diagonal. Okay. The edges are all diagonals of a face. If we close this one, we get the other one. We use the top face, but we join to the bottom. Okay. Again, this is a diagonal. So there are 2 of them. So it's better to see it one at a time. So for here, we have this. Just now the diagonal this way. Now we take the diagonal this way. So we have one vertex here, and then the other one is that side, which is very thin, very hard to show, but it's still a triangle, but only 3 vertices. Then here, just now we take the diagonal at the top face. Now take the diagonal at bottom and join to a vertex at the top. So we have the second triangle. For one diagonal, this diagonal to that side, and then if we take this diagonal, then to this side. Similarly, here we now take the other diagonal. Just now we take this diagonal. Now we take this, and then the third one is the next one will be this very thin. So 2, 4, 6, 8 lah. So there's one way of checking yourself. You can count by subtraction, and you can count the triangle. Next question. A graph consists of 16 vertices. This type of diagram is called a graph. So there are two types of graph. Those with the x and y axis on in coordinate geometry. And those that are consist of points and edges. So we have a graph of this type, 16 vertices, some edges that connect them. There are some edges, as in the picture. And N is now at the vertex label A. At each move, it can walk from one vertex to a neighboring vertex, crawling along a connecting edge. At which vertices labeled P, Q, R, S, T can the end be after 2019 moves? So N can be crawl repeatedly, crawl until 2019 moves. A move is along one edge. At each move, it walks from one vertex to another. So between two vertices is called a move. 2019 moves. So how to do this type of question? This one is graph theory, which is not taught in the school. And where if you take Form 6, then International Baccalaureate, they have the graph theory. I got teach before. But A-level and STPM, no graph theory. Further maths, last time got graph theory. Further maths, STPM, old syllabus. So doesn't matter. We know if you have graph theory, advantage. Let's draw a bigger graph. And then label the vertices. So I label all even numbers so that they are not joined together. And all the odd numbers also not joined together. So that means every time I got odd number, it will go to an even number. And if I have an even number, it will be going to an odd number. How to think of such idea is not easy unless you learn graph theory. This type of graph, it has one special name called a bipartite graph. What is a bipartite graph? It has two sets of vertices, two sets. One set, you notice, are all the odd numbers I put. They never join to each other one. Then the second set are all the even numbers, also not joined to each other. And every time a vertex from one set is joined to a vertex on the other set, one is always joined to even number. It can be joined to 2 and 4 like that. Then if 6 must join to 3 and 5 or 7. So this will help answer the question if you plan your reasoning according to the bipartite graph. Odd and odd number never join to each other. Odd always join to even. Always odd and even join to each other. So, okay, we mark the dots for them. Then let's take one example. Okay. Odd go to even, then even 1 go to 4. You can say A go to 4, 4 go to 3, 3 go to 6, 6 go to 7, 7 go to 10, then you go back to 9, go to 12, 12 go to 11, 11 go to 14, 14 go to 13, and continue. Always odd, even, back and forth. So you notice that if the number of move is odd, then it will land on an even number. 1 move, 2 move, 3 move. 3 move become even number 6. Then 4, 5. Odd number move will end an even number. 2000, in an odd number of moves, the end will always be at an even vertex. 2019 is odd, so it will be at an even vertex. If we study the diagram, P is odd, Q is even, R, S, and T all odd. Only one is even. So the 2019 is odd, so the end must be at an even vertex. Q is the only even vertex, so answer is C. There are many problems that can be solved by graph theory. The two famous one is the Chinese postman problem. They use graph. As a postman, you have to deliver letter to every house, to all the letters. So you don't want to travel back and forth. If you're a postman, you will have to sort out the addresses first, so that you don't over travel back and forth, back and forth. So you use graph theory. You can find the shortest distance to deliver all your letters. Then got the traveling salesman problem. If you are a salesman, like you deliver drinks to all the coffee shop, you deliver drink. You go to this coffee shop, then you go to the next coffee shop and deliver 1 crate or 2 crates of drink, and then you go to another restaurant. So you also want to know how to save time, you know. They will do those questions next time. They use graph theory. The answer is C. Only Q is even there. Because 2019 is odd. Next question. Okay. The positive integer A, B, C each have 3 digits. And for each integer, the first digit is the same as the last digit. 3 integers, all 3 digits, and all first digit and last digit are the same. And then B is 2A plus 1. So B is bigger than A. Then C is 2B plus 1. So C is the largest. How many possibilities are there for the integer A? How to start? We know C 3 digit, and since C is the largest, but also 3 digits, so it must be less than 999. Then we know 2B plus 1 less than 999. So 2B less than 998. B divided by 2, 499. Then B is 2A plus 1. So 2A 498. Divide by 2, 249. Yeah? So A is less than 249. A must have first digit and last digit the same, and must have 3 digits. So we can try to make a list and see, have a look. A has 3 digits and the first digit is the same as the last digit. So we have a look. If it's less than 249, so we list those start with 1. First digit is 1, last digit must also be 1. The middle digit can be 0 to 9. And then we can have those we start with 2. But we look at those digits start with 1 first. We look at this group first. Separately, we do later for those start 2. So this is our A. Then we can look at B. If we know A, we can find B. If we tabulate, first we times 2. Then we have first digit and last digit not the same, all not the same. Those that do have no carry forward, that it times 2, it don't carry forward. 141 times 2, no carry forward. But with 151, then the first digit become 3. We know that we must add 1. So we only consider those that has carry forward one. So that when you add 1, the last digit will be the same as the first digit. So when you make a list, you begin to see how the number works. So when you don't carry forward, the first digit always even, the last digit always odd. When you carry 1, then the number become odd. And then add 1, you will have first and last digit equal to 3. So there are 5 of them. We notice that 2 of them got carry forward. If we times 2 now, you want C times 2. All these out already because they don't have first and last digit the same. If times 2, add 1, 607, 647, 687. This one with times 2 because carry forward 72. 36 times 2 becomes 72. Then 3 times 2 is 6, add 1, 2b plus 1. So these two are the satisfy the condition. First digit and last digit the same for all 3 numbers. A if is 181 and 191, then the B will be 363 and 383, and C with 727 and 767. All have 3 digit, and for each of them, the first and the last same digit. Then we have to do for those starting with 2. So we stop at 242 because A is less than 249. So first digit and last digit the same up to 242. Then we double. We don't have to double. We know if no carry forward, it will be remain even. 24, 48 only, it will be remain even. Then if we add 1, all this will become odd. So the first digit is 2A is even. B is odd. Hence, B will not have the same first and last digit. Because the number, first digit always even, the last digit always odd. B is 2A plus 1. So no need to continue already because B cannot have first and last digit the same. Then there's no point calculating C. So therefore, answer is C. There are only 2 such number. If we write it down, there are only 2 values of A. A is 181 or 191. Then B will have first and last digit the same, 363, 383. And C will be 727 and 767. Okay, next question. One vertex of a square, on each vertex of a square, one positive integer is fixed. For another two numbers joined by an edge of the square, one is a multiple of the other. Okay. If joined, then multiple of the other. However, for any two diagonally opposite, neither is a multiple of the other. What is the smallest possible sum of the four numbers? This type of question, you can try and error a little bit. So we draw a square first. Then we want to label. Since it's smallest, we use small number. If we use 1 and 2, we know it's no good. 1, then all the number are multiple of 1. So let me show I choose 2 and 3. Start with 2 and 3 diagonally. Yeah, 1 cannot, because if 1 here, then this is also a multiple. So 1 cannot, because diagonally must not be multiple of each other. So 2 and 3 is the only, cannot use 1. So 1 smallest, then 2 and 3 are the two smallest. Then if we join, it must be a multiple. So you try to put 6 here. If we put 6 as a multiple of 2 and 3, then the fourth vertex must also be multiple of 2 and 3. So any multiple of 2 and 3 will also be a multiple of 6. So 6 cannot, if I put 6 here, then here we must put multiple of 2 and 3. Multiple of 2 and 3 is multiple of 6, but diagonally must not be multiple of each other. So 6 cannot, in other words, 6 cannot. Put 12. 6 is not suitable. The next smallest multiple of 6 is 12. If we put 12, okay, multiple of 3 and 2. Then we want a number not multiple of 12. Diagonally must not be multiple of each other. So we can see that you must use 18. We must be multiple of 2 and 3, but not multiple of 12. So the smallest is 18. What is the sum of the smallest possible sum of the four numbers? 18 is the choice, and then add up 3 plus 12 plus 2, it must be put there, equal to 35. Answer 35. Now, next question, number 8. What is the least number of elements we have to delete from the set? Our set consists of 10, 20, 30 until 90. So we want to throw away, delete, but as little as possible, least number of element, so that the product is a perfect square. So then we know perfect square must have even number of prime factor. Perfect square. So we write all the number in the product as products of prime factors. Okay. Then we count. First, we make the statement. Perfect square has even number of prime factors. So we count how many twos are there, how many threes are there, and 5 and 7. So tabulate. Tabulate the number of prime factors in the product, 10, 20 until 90. So 2, 3, 5, 7. If we count 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay. 3, only 4 of them. 1, 2, 3, 4. 5 got 10 of them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then 7, only 1. So you must eliminate 70. They cannot have 7 only one time. So we remove 70. When you remove 70, what happened? 70 is 7 times 2 times 5. So we 2 also remove, 1, 5 also remove. So become 15. 3 no remove. Here become 9. And then here no more. So we must have even number of prime factors. So we must remove and make this 15 become even and 9 become even. So remove 2 and 5. 10, remove 10. So here will be 1 less, 1 less. Then become 14, 4, 8, 0. Then 2 numbers removed already. So that's the least, the least number of element we have to remove is 2. Number 9. Okay, given a triangle ABC, area is S. The yellow one, ABC, area is S. Okay, yeah, ABC. Then D is the midpoint. D is the midpoint. Take points PQR on lines AD, AC, AB. Okay. Take on AB, you get P. Take on AC, you get R. Take on AD, you get Q. And then the length must be, AP must double 2AB. AQ, 3AD. AR, 4AC. Okay. So I draw bigger near. Now, what is the area of triangle PQR? This, is it equal to S, 2S, 3S, half S, or 0? It means PQR collinear. So we cannot draw by measurement. You have to do by calculation. So A, B, C, area is S. The yellow triangle ABC, area is S. So I mark one part of it as X. Then I calculate X using the length. They say here B, here is double, 2B. Then here 3 times, AD 3 times, and AR 4 times. So BCD, and then here all BCD. Then you use calculate the area. So X is half BD sine alpha. the two sides and the angle. There's a formula for area of triangle. Half BD sine the angle between the two sides. I proved this formula before last time. So if we calculate this triangle, you can know how many x. 2 and 3. Half 2, 3 sine alpha. So 6. Okay, 6x. 6 times. Area is 6x. 6x. The gray triangle is 6x. What's the plan? The plan is to find the gray and the dark gray. After we find already, then we subtract APR. Subtract APR. Then you will get PQR. So that's why I calculate this one 6x. So now I calculate this one. I call it y. Actually, x is equal to y because d is a midpoint. Question got say d is a midpoint. But I label y just to don't have too many x and then confusing. This again, how you do math. You don't want to people to like get confused. You want to make it easier to follow. Maybe just use y and a first. So y is C and D, CD sine beta. Then this one, 12 CD here. Okay, 12 CD, half sine beta, 12y. So this area is 12y. It's also equal to 12x. 12y, x and y equal 1. So the two triangle add up is 18 already. 18x or 18y. X equal to y. X equal to y. So S is the yellow triangle. Is x plus y is 2x or 2y. Now add the gray, light gray, and the dark gray. 6x and 12y is 6x and 12x, 18x, 18x. But S is 2x. So 9s divided by 2. So can we find APQ now? See? Because this ratio is 1 to 2. So the green area must double the yellow area because same vertex. 2x, 2y, because it's x plus y, and it's same height. Base is ratio 2 to 1, area 2 to 1. So then here is 1 to 4, 1 to 4. Blue is 4 times the yellow, 4x plus 4y. And then here 1 to 2. If you look at here 4, here APR double because 1 to 2 same vertex. You know, this triangle, this line, this triangle up to here only 8x plus 8y. Double this one because here is ratio 1 to 2. You look at this triangle. So share the same vertex. Base 2 to 1, area double. So we know the APQ and AQR is slightly bigger. This one is 8x plus 8y. 16x, 8s. So our triangle is the extra area, is subtract 9s minus 8s. Answer is S. Okay, next question, last question. If any digit of a given 4-digit number is deleted, the resulting 3-digit number is a divisor of the original number. How many 4-digit number have this property? So our number is 4-digit. A, B, C, D. Is can write as 1000A, 100B, 10C plus D. Then we want to form 3-digit number. So we delete any of the digit. If we delete A or delete B or delete C or delete D, all are divisor. So all will become integer. All are divisor. Divisible. So we look at delete A. If we delete A, then we got 100B, then C plus D. This is a divisor. So we write H times this equal to the original number N. This, you look carefully, you will come to a conclusion that the first term got 0, 1. The digit 0, there got 0, here got 0, here got 0, here got 0. But H is not 0. It's because you divide already, H is not 0. So D has to be 0 because all the other terms are 0 already. D must be 0. So if we divide D0, we remove, then we get to divide by 10, it will become 100A, 10B plus C, 10B plus C. Then you again see here got 0, here got 0, here got 0. This C has to be 0 because H is not 0. C other number cannot already because our number must end with 0, 1. So C is 0. When C is 0 already, we can divide by 10 again, then we get 10A plus B, and then HB. So far, we know 2 of the digit already, and they forced to be 0. These 2 must be 0, CD 0, 0. Here, D 0, here, C 0, like that. So if we write it out, it's, if we n over, if we delete the 0, then 1 0 left. 1 0 left. Then we divide, it's 10. If we delete B, then we got A0, 0. Number is A, B, C, D. We'll delete the second digit. Then we got A0, 0. So A, B, 0, 0, divide. You get AB over A, which is 10A plus B over A. 10 plus B over A. If we delete A, the last 2 digits are 0 already, so the number become B0, 0. So cancel AB over B, then we got 10A plus B over B. B over B is 1. Then A over B. So how does this help with it? We know the last 2 digits is 0. So we need to find A and B only. Yeah. Force already. C and D forced to be 0 already. Now we look at B over A. Maybe B equal to A is one case, and then B not equal to A is one case. B is a multiple of A, and then 10A is a multiple of B. We write that down. B equal to A. If A not equal to B, then B is MA. B is a multiple of A. B bigger or 10A is bigger, then 10A can be divided by B. So 10A is N times B, multiple. Okay, the condition must be satisfied because the number, we delete the number must be all integer when you divide. So we must solve the equation. So B is MA, substitute this MA inside here. N MA, A and A cancel. 10 equal to MN. The M is 2, 5 or 5, 2 like that. When A not equal to B, here must be a multiple is either 2 or 5. So we look at A equal to B first. If A equal to B, AB become the first case. A equal to B, I don't have to change because I cancel the 0 only. Then I always get 10. If I delete the 0, then this one, the last case, delete the 0. So AB 0. Then you always get 10. But if you write AA00, A equal to B, and delete the B, you get A00. If you write BB0 and delete the A, then you get 11. So this allows us to form the number. Is when you delete A, you get 11. If you delete B, you also get 11. If we delete the 0, we get 10. So if you delete the 0, we get 10. If you delete A or B, it will always be 11. 20, I think got show example. Later only I show. If A not equal to B, then is substitute. If M is 2, then B is 2A. 2A, B is 2A. If here is 2A, then we cancel. N is 5. 5 times 2A is 10A. If we put 5A, M is 5A, then here is 5A. The N is 2. 2A times 5A also 10A. So B is either 2A or 5A only. Okay. M is 2 or 5 only. This still also give the same relationship. B is 2A or 5A. So if B is 2A, if A is 1, 2, 3, 4, and B is 2, 4, 6, 8. Cannot have 5. 5 is double, it come 2 digit. A, B, C are digits. A, B, C are digits. All less than 10. So we can have form numbers with these values of A, B, C. If B is 5A, then A can only have one value, 1. Then B is 5. So we have 5 cases. The example, if B is 2A, then 1, 2. B is double, 1, 2, 0, 0. Remove the 0, you get divide by 1, 2, 0. If you remove the 2 and divide by 100. If we delete the 1, we divide by 200. So we get 10 or 12 or 6. You can see from here, if here is 2A, then you get 11. B is 2A, sorry, B is 2A, B is 2A. So 10 plus 2, 12. If here B is 2A, then 10 over 2 is 5. 5 plus 1 is 6. You will get 6. Okay, this one is just for show, to see so that we have a picture of the answer. So B 2A, so 2 then 4, 3 then 6, 4 then 8. And if you delete the 0, you get 3,006 divided by 360 lah, 10 lah. Then here 12 and here 6 lah. So always 10, 12, 6. When you come to 5a, then if we delete the 0, again 10. But if we delete the 5, then you get 15. If you delete the 1, then 15 over 3 over 5 is 3. If you check, if here is 5a, then 15. 10 plus 5, 15. If b is 5a, then we get 10 over 5 is 2. 1 plus 2 is 3. There you get 3. The other one always 10. Always 10. Huh? This one always 10. So we get 5 more numbers. A and double one. B is double A, or 5 times A. When 5 is only one case. So 9 answer plus 5 answer, 14 answers. 14 answers. Answer is C. If you ask, maybe in your mind, you say, hey, what about 10 times 1? 10 times 1, then B is 10A. How can B 10A? B is a digit. Digit cannot, unless A is 0. Then A 0, B also 0. Then our number is 0, 0, 0, 0. That's trivial. Okay, so it's good to question. Why no 10 times 1? So let's see the internet. Kangaroo match competition. Malaysia one. Go and check. Coming already. They never put a date. Competition day, 22nd April. Okay. All right. We stop here.